Thanks for joining me again. We're going to be continuing our discussion on the binomial distribution, and actually the goal, at least in writing here, is exactly the same as the previous video. We're going to calculate probabilities for random variables that are binomially distributed, but we've already kind of introduced the concept. What I'm trying to do in this video is teach you the notation that goes along with binomial distributions, and also I'm trying to teach you how to use your calculator in order to assist you in the calculation of binomial distributions. It's going to be absolutely your best friend, just like it was for other statistical type things that you've done over this course. Now, let's go ahead and take a look at those two things that I just mentioned, notation and calculator commands. First of all, whenever a variable is binomially distributed, a random variable, binomially distributed, here's the notation that you use to represent that. All right? If the random variable is x, we'd say that capital X is, and this looks like the similar sign, approximately binomially distributed. Now, keep in mind, as I'm teaching this notation, the things that are required for a binomial distribution. First of all, in a binomial distribution, you're only concerned with whether you have success or a failure. You always have a two-outcome random variable. All right? And another thing is that you need a fixed number of trials. Each of those trials also needs to be independent of the other. All right, so keeping that in mind, since there has to be a fixed number of trials, one of the things that's done with the notation for binomial distributions is they have you specify in the notation what the fixed number of trials is in. All right? And secondly, the other most important piece of information about a binomial distribution is what is the probability for success. And so that is always specified whenever you're trying to say that something is binomially distributed as well. So for example, let's say that there was some random variable p that was binomially distributed, and in this binomial distribution there were going to be 7 trials, and the chance of success was 0.92, a 92% chance of success. Well, that's how you would write that there were 7 trials and a 92% chance of success. Make some sense? All right, great. You're going to see that notation quite a lot in your book. Now I'm going to label a couple things with that we just mentioned verbally, so you can write those down if you like. And then I'll go ahead and teach you how you can use your calculator in order to calculate probabilities based on such a binomial distribution. All right, there's exactly what that notation means for that specific example that I gave. Now, let's go to a hypothetical so that we can talk about the calculator commands. Now, in our example, we're going to assume that there's a random variable x that that's binomial distributed, and it's going to have 20 trials with a 0.38 chance of success. Okay? What I want to do is show you how you can use your calculator to find the following things. Beginning with how you would find the probability of a specific number of successes occurring in that trial of 20, in that trial size of 20. We're going to see what is the probability of getting 11 successes under those parameters. Now on your calculator, and I'm speaking about TI83s and 84s, not speaking about Inspires or Cassios or anything, sorry. You can find the similar commands on those calculators though. On the TI83 and 84, the command that you're looking for with binomial probabilities, there's actually 2 of them, but to find the probability of a specific number of successes occurring in a binomial distribution, you're looking for something called Binomial PDF. Now let me write that out for you. Binomial PDF. And I'm going to tell you what that represents, and I'm going to tell you the way of inputting something into that function on your calculator. Now the PDF stands for Probability Distribution Function. And a binomial probability distribution function is not the only PDF function that you have on your calculator. Now, of course, that won't be much to you until you know where you go in order to look for the binomial PDF. And on the TI83 and 84, the place where you go to look for that is second/distr for distribution. All right, the distribution button there is right above your vars or your variables button. And if you'll go to second distribution and then look for Binomial PDF, just scroll down that first column that it gives you. It's choice A on my calculator. Then it'll bring up the Binomial PDF, probability distribution function. All right, now there's a certain way that you have to format the input for Binomial PDF. Actually, you have a couple options, but for what I'm going to want you to do, here's how you're going to do it. You're expected to enter 3 arguments for Binomial PDF. Okay, for the way I'm showing you anyway. And the first argument is how many trials are there in your binomial distribution. The second argument is what is the probability of success. And the third argument is what I'm going to call R, which represents the number of successes. Let me label that. Actually, let me kind of translate using probability notation what this gives you. That equivalently is the same as finding the probability that a random variable x is equal to a certain number of outcomes r. Okay, so in this case, it would be the probability that x equals 11. We would put an 11 right there where the r is. All right, so we're going to try to find the probability that x is equal to 11. So you're going to use that binomial PDF, and here's what you're going to write with it. Simply put in 20 for n, put in 0.38 for p, and then put in 11 for r, and let your calculator do the rest for you. Now, as you might expect, if the probability of having one success is only 38%, that the probability that you'd be successful 11 out of 20 times is not going to be huge, and that's kind of backed up here. To 3 significant figures, the probability of 11 successes was only 0.0542 in this particular binomial distribution. About 5.42% of the time, you're going to have 11 successes there. All right, great. Hopefully that makes a little sense. We'll see this in the context of another problem in just a moment. The next thing I need to show you how to do is how you find the probability of up to a certain number of successes. So say you want to find the probability that you have up to 7 successes or up to 14 successes. All right, here's an example. Let's say we want to find the probability of having up to 6 successes. We'll just use that number. All right, now it's possible to do this, but I wouldn't recommend it. If we're trying to find the probability of having up to 6 successes, then that means we need to include the probability of having 0 successes, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6 successes. That would be 7 different probabilities that we'd have to add together. And we could use the binomial probability distribution function up here 7 times and then just add those results together. But it turns out that there is another way that kind of does that for you, where you don't have to worry about using binomial PDF 7 times for the same problem. Okay? If you ever want to find the probability of up to a certain number of successes in a binomial distribution, rather than use the binomial PDF function, what you're going to do is you're going to use the BinomialCDF function. Now, the C is the thing you need to define here. You know what the D and the F stands for, distribution function. The C stands for cumulative. This is the binomial cumulative distribution function. And so what it's going to do then is it's going to calculate just in one entry on the calculator what the probability that we get up to 6 successes would be. All right, it sums up the probability of getting 0 success with the probability of getting 1 success and 2 successes and so forth. All right, now it turns out you enter basically the same information for a binomial CDF that you do for a PDF. You have to tell it what the number of trials is, you have to tell it the probability of success, and you have to tell it the number of successes that you want it to count up to what you want it to calculate the probability for. So if I were to write the probability notation that goes along with what this tells me, it would tell you the probability that a random variable x is less than or equal to some number of successes r. All right, perfect for what we're trying to accomplish right here. Now, in this case then, go and type in binomial CDF of 20, 0.38, 6, right? And that's telling us that we've got about a 31.2% chance, 0.312 chance of getting up to 6 successes in this particular binomial experiment. All right, great. Now there's only one more possibility that I need to teach you here. I've shown you how to find the probability of a specific number of successes happening in a binomial distribution. Then I've shown you how to find the probability of up to a number of successes occurring. Now I need to show you how you find the probability of at least a specific number of successes occurring. Now it turns out there's not a new calculator function that does that for you. The BinomialCDF is actually the one that we're going to use, but we've got to know how to use it. All right, so that's what I'll show you here. Let's say that we wanted to find the probability that we get at least 5 successes. Okay, so I said we're going to use BinomialCDF again, but I need you to have the logic behind why and how we're going to do that. If we're going to find the probability of up to 5 successes, but our calculator only knows how to, of at least 5 successes, but our calculator only knows how to tell us the probability of up to a certain number, well, we have to start using the complement of the event. The probability that x is at least 5 is equal to 1 minus the probability that x is less than 5. All right, the equal to part really doesn't matter for us overly much here. On second thought, I think I better take the equal to part out of the original problem for what I'm wanting to show you here. Because the BinomialCDF, when you type it in, will include 5 as one of the successes. Just trust me on that. So we want to do 1 minus the probability that x is up to 5 successes. So that's going to be 1 minus BinomialCDF, 20, 0.38, 5. Try it out. There's what you're typing. And the result is we see that we're going to have about a 0.833 chance, an 83.3% chance of getting at least 5 successes in this binomial experiment. All right, so there's the calculator notation. Now this is very important for you to hear the next little bit that I say. IB is very specific in telling students and examiners not to just write down calculator notation on their exams. So I'm just having to write this down because in this video format, the way I can communicate to you what you're doing on your calculator is to write out, for instance, Binomial PDF and write the arguments here, but that's not what you're going to write on your calculator. What you're going to write on your calculator, for instance, is right here. The probability that x is greater than 5 equals 1 minus the probability that x is less than or equal to 5. And then you're just going to skip down and show what the answer is because it's assumed that you've done that on your calculator. But don't write down calculator notation. All right, you've been warned. Now, let's go ahead and apply this to an actual problem. On a sunny day, there is a 55% chance that Pierre goes running. Given that it will be sunny for the next week, find the probability that Pierre runs, first of all, 5 days, then no more than 2 days, and then at least 4 days. All right, well, let's start off with the Pierre goes running 5 days. And also, I'll tell you what, before we even do that, let's see if we can understand what the parameters here are for our binomial distribution. And when I say the parameters, what's the trial size and what's the probability for success? All right, if we call this chance that he goes running, if we let the random variable r represent that, we would say then that r is binomially distributed. And if it's going to be sunny for the next week, we're trying to say that there's going to be 7 days in which he could possibly go running. And then there's a 55% chance on each of those 7 days that he will go running. Okay, so those are the parameters. That's our P and our N. So for 5 days, we're trying to find the probability that R equals 5. Now I'm going to trust that you understood the calculator notation on the previous slide. If you didn't, go back and see how you would type that in. You're going to use a binomial PDF function. I'm now going to model the notation you'd use on your IB exam, so I'm not going to write out binomial PDF, but use binomial PDF and put in, of course, 7 and 0.55 and then 5. All right, so approximately 21.4% chance that he goes running 5 days during a week. Next, we're going to find the probability that Pierre goes running no more than 2 days during a week. So, the probability that R is less than or equal to 2. Now you know that you're going to use a cumulative distribution function here, and this is exactly the way it's set up, is to tell you up to 2 successes what's the probability. So go ahead and use your binomial CDF, please. Now this is pretty small, as you might expect. The probability that he goes running no more than 2 days is only about 15.3%, excuse me, to 3 significant figures. All right, if he goes 55% chance on any one day, he's probably going to go more than 2 days, you would think, right? Okay, and then the probability that he's going to run at least 4 of those days. Now, I get the chance to amend kind of an earlier misstatement here that I made on the previous slide. Let me attempt to do that. We're trying to find the probability that R is greater than or equal to 4, right? That we have at least 4 successes. Now, theoretically then, that's the same thing as 1 minus the probability that he has fewer than 4 successes. Okay? But the way we need to think about it is not 1 minus the probability that gets fewer than 4 successes, because if we type 4 into the binomial CDF for our calculator in this, it's not going to give us the answer we're going to want. It's going to include the 4. We don't want it to. What we want to do instead is think of this as the probability that he has less than or equal to 3 successes. Now, you can't have 3.2 successes, so it's completely fine to go ahead and change that to a 3. Make sense? I'm hoping so. All right, so do 1 minus binomial CDF. You know the numbers to type into that function. Go for it. All right, now this answer makes a lot of sense too. There's about a 60.8% chance, and you can write these as percentages, by the way. I'm not, but you can. There's about a 60.8% chance that he's going to go running at least 4 of those days. All right, excellent. So in the previous video, you learned the concept and the formula associated with calculating a binomial distribution, and now you know how to use your calculator to assist you in that. Such a boost to have that calculator as your friend in this endeavor here. All right, thanks for your attention, guys. Hope this helps out quite a lot. See you next time.